It's the end of the fourth week in August 2025. We went from learning about wastewater contaminants boosting green hydrogen production to peering into a newly forming solar system before learning about the potential explanation for where the antimatter went. Let's take you on a deep dive. Well, following an issue with ground systems earlier this week, Starship Flight 10 took to the skies above Boca Chica Beach in Texas on Wednesday morning Australian time. It's the first successful flight of the year for Starship, with flights 7, 8 and 9 failing just after liftoff, and what would have been the 10th blew up on the pad in June. Research led by RMIT University has developed an experimental invention to turn wastewater's high contaminant load into an advantage for making green hydrogen that could reduce reliance even on fresh water, a scarce resource in many parts of the world. The team's approach harnesses some of the contaminants in wastewater to speed up hydrogen production and overcome high contaminant loads that normally makes wastewater unusable. Lead researcher, Associate Professor Nasir Mohammed from RMIT's School of Science, said the team found a way to capture platinum, chromium and nickel, as well as other metals, in the water and then put these elements to work to enhance green hydrogen production. Their experimental invention comes in the form of electrodes, which are key components for splitting water into hydrogen and oxygen. The electrode is made with an absorbent carbon surface that attracts metals from wastewater to form catalysts that are stable and efficient at conducting electricity, helping to speed up the water splitting. As part of the experiments, the team used the wastewater samples in a container with 2 electrodes, an anode and a cathode, and powered the water splitting process with renewable energy. When electricity flows through the water, it causes a chemical reaction. At the cathode, water molecules gain electrons and form hydrogen. At the anode, water molecules lose electrons and form oxygen. Co-researcher Dr. Mohammed Harris said further research was needed to refine the catalyst process, making it even more efficient and suitable for commercial use. A critical water source for vast areas of Australia's Northern Territory is drying at an accelerating rate, according to new findings, with losses clearly visible from space. The Cambrian limestone aquifer is a large interconnected limestone system containing high-quality groundwater that supports numerous NT rivers, towns, Indigenous communities, pastoral enterprises and irrigated agriculture. But the findings, published in a new study led by Griffith University researchers, show the aquifer has experienced significant water loss since 2014, reaching its lowest recorded storage level in 2021 at the end of the study period. The study draws on 2 decades of data that started in 2002 and includes ground-based bore monitoring from the Bureau of Meteorology and remote sensing from multiple satellites, one of them being NASA's GRACE satellite, which is used to track groundwater depletion globally. It does this by detecting subtle changes in Earth's gravity, indicating how much water has been lost underground. This drying trend occurred despite fewer severe droughts during the 2011 to 2022 period than in the previous decade. The earliest formation of planets around a star has been captured by our long-range telescopes, according to international researchers. Combining an image from the Atacama Large Millimetre Submillimetre Array with data from the James Webb Space Telescope, the researchers have observed hot minerals around a baby star called HOPS 315 that are beginning to solidify, a process that will likely lead to the development of planets around the protostar. Melissa McClure and colleagues studied HOPS 315, located in the Orion B molecular cloud around 420 parsecs from Earth. The protostar is positioned in a way that allows a direct view of its inner gaseous disk through a cavity in its outer envelope. When they compared these observations with models, they suggest that the conditions resemble those necessary for the formation of planets similar to those in our solar system. Ichthyosaurus had a specialised serrated fin for sneaking up on prey in dimly lit parts of the ocean, new fossil evidence suggests. The Giant ancient sea dwellers are reptiles that transitioned back to living underwater, much like the mammalian ancestors of dolphins and whales. The researchers say that modern shipping and sonar is disrupting the hearing of today's ocean dwellers, but the fin serrations and surface texture of ancient ichthyosaurus could help human engineers reduce our noise pollution under the sea. John Lindgren and colleagues present fossil evidence of a unique front flipper from an ichthyosaur which lived between 183 and 181 million years ago. The flipper fossil, excavated in southwest Germany, is approximately 1 metre long and features a wing-like shape with a serrated edge and a flexible tip. Lindgren and colleagues suggest that the fin was used by the reptile during hunting. More specifically, through computer fluid dynamics simulations, the authors propose that the serrations on the fin likely helped reduce noise from the reptile as it hunted prey in those dimly lit marine environments. The authors note that hearing has long been a crucial sense amongst seafaring creatures, and in the modern day, that sense is disrupted by human activity, such as shipping and military sonar. Lindgren and colleagues suggest that the fin serrations and surface texture of the ichthyosaurus could serve as a blueprint to reduce our noise pollution in the open ocean. A difference in the behaviour of matter and antimatter has been seen for the first time in the subatomic particles that make up most of the observable universe, and it might help explain why there is more matter than antimatter in the universe. The Big Bang should have created equal amounts of matter and antimatter, but there is far more matter in the universe, and one of the keys to explaining why is finding a difference in how matter and antimatter behave, known as charge parity violation. Using the Large Hadron Collider at CERN, Zhitang Yang and colleagues of the LHCb experiment have seen this difference for the first time in a type of subatomic particle called a baryon. Baryon particles include neutrons and protons and make up most of the matter we can observe in the universe. While such a violation was predicted and does not resolve the Big Bang matter-antimatter imbalance, finding out the details of this violation experimentally will offer important clues, opening up opportunities for further theoretical and experimental studies of the nature of CP violation. We're in the white void as we prepare to bring you a set refresh, so stand by for that. Daily science and space stories in the meantime continue with an Aussie flair, plus a deep dive into the science or space headline of the week, as well as the occasional science fiction podcast. I've got to do some more of those. Got to get to a convention. Like, follow and subscribe for more. Membership available to help me do more. That's at the Trek.zone/support. This is Trekzone's Talking Science.